So Unit 4A is all about circles, and there's quite a bit of vocabulary that you basically need to know and understand in order to be successful in the unit. So first, we'll go over some basic definitions, things that you have heard or maybe even seen before, but there may be words on here that you haven't. Now, one thing I want to mention is that a lot of times the definitions may not seem very clear from things that you already know, like a circle. We basically feel like, okay, we know what a circle is. But if you look at the definition, and I'm going to just underline the parts that are very commonly written on tests, this first part. Now, obviously, this part wouldn't necessarily be given because it gives away the actual word. But if someone said, what is the set of all points equidistant from a point called the center? You may not even think of a circle. But if you really break down the definition and what it's talking about here, the set of all points equidistant. Now, equidistant means equally distant from a given point called the center. So we have a given point. So if I just kind of draw, you don't have to do this on yours, I just want to explain this. Draw some given point. And I draw now the set of all points that are equidistant from that. So let's say, I went out 2 centimeters up, went out 2 centimeters down, all the points that are 2 centimeters away from that center point. If they were all 2 centimeters away, as you draw more and more points that are 2 centimeters away from that given center point, you'll see that it'll eventually form a circle. Now notice it said the set of all points. So obviously you'd have to fill in all the gaps, and as you fill in the gaps, the actual line, or a curve, I should say, that creates the circle is becoming more and more apparent. So that's basically how the definition is what it is. And as I mentioned, you may see this on a test and not have any clue or not necessarily think to match it with the circle. So it's important that we basically draw it out, do something to understand what these definitions are referring to, because you may see definitions like this on a SAT and ACT, and then of course tests, something like that. Alright, so now let's go ahead and get to what you need to mark on your vocabulary sheet for a circle. So it's just basically giving us the definition. We need to know how to name a circle. So when you name a circle, they'll often give you a point and name it in the middle. You name a circle by the center. Now, the letter there could be any letter. I just used P. But there's a few ways that they would name this circle. They could say circle P by writing out the word circle, or you can just put a circle with a dot in the middle and put the letter P. Those are the two ways to name a circle. So definitely jot that down. It's important that you know how to name each of these vocabulary words that we're going over, or each of these things. So the next thing is a chord. Notice that a chord says it's a segment whose endpoints are on the circle. So remember that a segment has 2 endpoints. It doesn't continue forever, it has endpoints. And it says that they're both on the circle. So basically, we just need 2 points on the circle, and we're drawing the segment between them. Notice I did not go through the center, and that is because the center is a special segment. The segment that goes through the center is a special segment, which we'll talk about here in a second. Now, to name a chord, just like you name any segment, we need to have some labels on the endpoints. I just used A and B. You can use any other letters you prefer. But to name a chord, you just simply name it how you would name a segment, by putting the letters there and then a segment across the top. Remember, the line on top there is important. It has ends. It's not a ray, and it's not a line. So it's very important you put the segment across the top so we know it's a segment, not a line or a ray. So the next one is diameter. So hopefully diameter is very familiar to you. You should have heard it in other classes up to this point. So a diameter is, just like it says here, the distance across a circle, but through its center. So notice I went through the center there. So it kind of is like a chord, being that it does have endpoints on the circle, but it's special because it goes through the center. And we name it the same way we name a chord. So we can just use 2 letters and a line across the top there, or a line segment across the top. So hopefully you also are familiar with the word radius. It's the distance from the center to a point on the circle. So now we're starting at the center and going to a point on the circle. And we can label our center with a letter. I'm just going to use PT for some reason. I don't know why. But it just, as long as you have a letter on the beginning of the sentence segment and a letter on the end. Now, the same way I named these AB, I could have put BA. You know, it doesn't matter which direction you go as long as you start at the end and go to the other end. Same thing here. I can call this PT or TP. So this radius is PT, or we can call it TP. So once again, it is a segment, but it's a special segment because it goes from the center to the edge. Now there is a relationship between a radius and a diameter. Hopefully you see, and hopefully you remember from maybe middle school, that a radius is half of a diameter. So basically a diameter contains 2 radiuses, which we say radii when we're naming more than one. So it has 2 radii inside of it. That's why one radius is a half. So I'm just going to put that as a note, and I think you should because we actually use that fact a lot. The radius is half the diameter. And we use this because we can be given, you can pause me at any time since this is a video in case I'm talking too fast while you're writing. But the radius here, let's say we knew that length, and you don't have to write this on there. I'm just going to put some numbers on here. Let's say we knew the radius was 7 inches. Well, then you should know how long a diameter would be, because if a radius is half, that means the diameter should be 14, because it has 2 radii in it. So that's how you use that relationship, knowing that that radius is half. Another example, let's say I have the length of the entire diameter. Let's say we know this is 20. Well, then I should know that the radius would then equal 10, because it's going to, your diameter contains 2 radii, so it has to add up to 20, or basically you just divide by 2. All right, so if you know which one's longer, which one's shorter, you should be able to either multiply by 2 or divide by 2 to get an answer if you're trying to figure out length from a radius to a diameter or vice versa. All right, the next word here is secant. A secant you may not have heard before in the past, but a secant says it's a line now. It's not a line segment like we've seen before, it's an actual line. So that means it continues in both directions, and it intersects the circle in exactly 2 points. So a line that intersects the circle in 2 points. So I can have an intersection here, that's 1 point, and I can intersect over here, that's 2 points. So notice it's going through the circle. That's the difference between a secant, it goes through the circle, so that's why it uses the word line here, versus a chord, which is a segment. It has endpoints on the circle's edge. So that is the difference between a chord and a secant. A secant goes on in both directions, or basically it's a line. And because it's similar to a chord, once again, the notation is very important. So I'm going to name this same thing as I named the chord up there, just so you could see the difference in the notation is going to be what you put on top of it. I know now that that is a line rather than a segment. And once again, it could be AB or it could be line BA. So either way, that secant is going through the circle, intersecting it in exactly two places. Now the difference between a secant, which intersects in 2 places, and a tangent is that a tangent intersects in exactly 1 place. So a lot of students, and I wouldn't draw this yet, but a lot of students who try to draw this based off the definition, they do the same thing. So I want you to pause and try to draw first what you think this is going to look like on that circle. So a line that intersects the circle at exactly one place or one time. So pause, try to draw it first, and then you can unpause to see what you drew. Or if you drew it correctly. So first off, what most students do is they do this. They say, okay, it only intersects it once. But that does not satisfy the definition because remember it has to be a line. So remember a line continues in both directions. That's the difference between a line and an array or a segment. It would continue that way. And if it continues, that means it's going to hit again in a second place. So therefore it would not be a tangent if it is a line. So that's what most students draw. That is not correct. The correct drawing, in order to touch the circle in exactly one place, you cannot go inside the circle. You have to actually graze the circle. So this is a tangent. A tangent is actually on the outside, a lot of students like to say, but it grazes the circle. It just barely touches it and just bounces right back off. It does not go in it. Nowhere in the definition did it say it had to be on the inside of the circle. All right, that's actually a hard one for students to draw. So if you drew that when you paused, then good job. Now we need 2 points, at least 2 points to name a line. So I'm just going to put, 2 points on here. Let's call this PT again. And notice, since it is a line, we do need to put PT with a double arrow line across the top. Now the next word that's inside of this box is point of tangency. Well, point of tangency is just the point where it grazes the circle. So I'm just going to use a different color there and draw an arrow, and we're going to call that point P is the point of tangency. All right, so that is our point P. I'm actually going to make it in blue there. Okay, so we have a point of tangency, and then we have the tangent line itself is PT. So the next word you probably heard before, well, hopefully you did, because in middle school, you most likely used the formula to calculate the circumference. So the circumference is simply the distance around the circle. If you think of a circular skating rink, if you skated the distance around the edge of the skating rink, you would be, traveling in some linear measurement like feet or meters. But yeah, you would be able to say, okay, well, that was 100 feet or something like that. So the distance around the circle is the circumference. So really, the only thing I could really draw to show that we're talking about the distance around is maybe like a continuous arrow, something like that. Now, there is a formula for the distance around a circle, and you probably have seen it either written as C equals 2 pi r. We will be using the pi button in this class. In middle school, you probably learned that pi was 3.14 as an estimate for pi. Well, if you actually grab a calculator, hit the pi button, you will see that pi is actually a decimal that continues on forever. So we actually are going to use the pi button on your calculator to be more accurate than you were in middle school. So make sure you guys understand where on your calculator that pi button is, because we will be using it this unit. Now, another way that they write the formula, because if you really look at it, and we said earlier that two radiuses is the same thing as one diameter. So instead of writing 2r, because this is 2 times pi times r, instead of writing the 2r part, a lot of times they may write it as just pi d, because 2r's is the same thing as diameter. So we can write that as just pi times a diameter, since that's the same thing as 2r's. So those formulas could be used to find or calculate the circumference, the distance around the circle. Now for the area of a circle, hopefully you are familiar with the word area. Remember, area means the space inside. So since we're talking about the area of a circle, we're talking about the space inside the circle. So if this was like a pizza, for instance, we're talking about everything, the cheese. the circumference would be talking about the crust, and the area would be talking about all the cheese and all the stuff on the inside. So how much stuff or how much space is taken up there. So the formula for the area of a circle is that A is equal to, hopefully this one looks familiar too, pi r squared. Very short formulas to use. Notice all you do is you need a radius, of course, but you square your radius and you just multiply by pi, and that gives you the area or the space inside of the circle. So the next word is a sector. You probably haven't learned about sectors in middle school. Maybe you have, maybe you haven't. But either way, a sector is just kind of like a pie piece or a pizza slice. It's just a section of your circle or a portion of your circle. So to draw that, we basically need two radiuses or two radii. And notice you could just draw two radii anywhere. I'm just going to draw like that. And they form what's called a sector. So notice there, this is like a pie piece or a slice of pizza. This is a sector. It's a section of the circle. Now we need to know about sectors, because what if we don't want to know the area of the entire circle, but we wouldn't just know the area of that piece? Or what if we just want to know, if we were going along that skating rink, what if we found out that, oh, well, my friend's over here and I'm over here. How many feet am I traveling to get to my friend? So maybe I just want to know a portion of the circumference, which is called arc length. If I just want to know the distance around the circle, but that I traveled, that wasn't the entire circle, if I just want to know a portion of that, that's a fraction of the circumference. So the formula for that, I'm going to start with the formula here. The formula for arc length is really just a fraction of the circumference. So we're going to end up having the degree of the arc. So it's the degree of the arc divided by 360 times, it's a fraction, once again, that's our fraction part. It's a fraction of the circumference. So I keep saying that because it's just that fraction times the circumference formula, which is 2 pi r, or pi d. So that is the total arc length formula. So just to draw that there, let's say we wanted to know the distance from here to here. So let's say this is arc AB, and we wanted to know the distance there. So we'd be given, like I said, and you'll see this later on in the unit, you'll be given what degree this arc is. So if you look at it, well, hopefully you guys remember that the distance around an entire circle, or the degree of a full circle is 360 degrees. Half of a circle is 180 degrees. So an arc that is about half of that half is about 90. So yeah, it makes sense for this to be about 90, 92, 89, something in there. But that degree, once you know it, you wouldn't guess it, it'd be given. You would put here, and then you would just divide by 360 and multiply by 2 times pi r. But like I said, we'll talk about that when we get to it. And the area of a sector formula is basically very similar in the sense of what we're doing. We're taking a fraction, so a portion, of the circle's area. What if we don't want to know the entire area inside? We just want to know this piece. Maybe this is our pizza, and I want to know how much, my sister ate. What portion of the pizza my sister ate. So I can figure out how much of the pizza she ate by doing something very similar with the area of a sector formula. So area of sector, it equals a fraction, so the same fraction there, theta divided by 360, remember theta represents the degree, times the area formula, pi r squared. So that's how we will calculate the area of just a sector, not the whole entire circle, but just a portion of it. Alright, so now moving on to different types of arcs. I'm going to start in the middle here with a semicircle. A lot of you guys are familiar with the semicircle, and you know that it's half of a circle. Well, in order to know that something is half of a circle, I kind of need a diameter. So if we have a diameter, now that dashed line is not the semicircle. The semicircle I'll put in, let's do pink. So the semicircle is the actual circle, half of the circle itself. So that pink arc there is a semicircle because it's half of a circle, and I know it's half the circle because the endpoints are basically the endpoints of the diameter. So I can call this A, and I could call this, let's use a different letter, like T. But when you name a semicircle, you are going to need three letters. Now, they may put multiple points on here, but you only need 3. So I'm just going to call this C. So when you name an arc, this is the first time we're naming an arc. When we name an arc, you want to make sure you name it using the letters in order. So what I mean by order, you can either go ACT or you can go TCA. You do not want to go CTA, because notice what I just did there. When I named that, it created an angle. That creates an angle, not an arc. You want to make it round. So A to C to T, or T to C to A. So either of those ways to name a semicircle are perfectly fine. So the only thing is, you have to remember, I'm going to put or, TCA. Now you have to remember 3 letters can be used to name a triangle. 3 letters could be used to name an angle. So it's very important that you show you're talking about an arc by putting an arc over those 3 letters. That's how we know we're talking about arc ACT and not angle ACT or triangle ACT. So it's very important you understand the notation and you use it. Now, one thing to mention about a semicircle that you guys probably already know, since we discussed an entire circle is 360 degrees, you should know that a semicircle is half that, which is 180 degrees. So measures 180 degrees. All right, so I did that one first because a major arc and a minor arc are basically referencing a semicircle in a sense. So a major arc is just more than a semicircle. So anything more than half the circle. A minor arc is something less than half of a circle or less than a semicircle. So if I draw a major arc, I just need to go more than half of a circle. Tracing is kind of getting bad there, but notice I am just going more, trying to make it a little darker than that line behind it, more than half the circle. And you absolutely have to name this with at least 3, or not at least, with 3 letters. That way we know we're talking about a major, not a minor. So 3 letters to name a major arc. So A, B, C, we can name it, or we can name it going the other way, but remember order matters. You could name it C, B, A. You cannot name it B, A, C, because that is not in an order that'll make the arc. You want to make the arc with your letters. C, B, A would make the arc as well. So I'm going to just put or, C, B, A. Make sure your arc is on the top. Now, one thing to note here, very much like we noted that the semicircle measures 180, that a major arc measures more than 180. So it measures more than 180 degrees. That's a major arc. So hopefully you already can tell what we're going to draw for a minor arc. So a minor arc is going to measure less than 180. So it could really be any small arc. It could be that size, it could be this size, as long as it's less than 180 degrees. So I'm just going to make mine this big because it is less than a semicircle. Now a minor arc you can actually name with 2 letters. That's how we know it's a minor arc, because it's named with 2 letters. What you don't want to do is have 2 arcs. You don't want to have a pink one and a blue one and not know which is which. So what I mean by that, let's say we have some other third random letter over here, C, and you don't have to draw what I'm drawing here in blue. But there are 2 arcs here. There's an arc AB and there's an arc ACB. ACB is the major arc. I know it's major because it's 3 letters, but I also know it's major because A to C to B is that blue one, which is the major. You cannot name, let me erase this for a second. You cannot name that blue one AB. You cannot name it AB because it's a major arc. So that's why we know that we are naming small ones, our minor arcs, with just 2 letters. When I read that, I know it's less than 180 degrees. So remember, you can also name it going the other direction. We can also name it B to A. But remember to put the arc over it. That's how we know it's not talking about a line. It's not talking about a line segment. As you could see in these other vocabulary words, AB could be used to name a segment, could be used to name a line, but it could also be used, using 2 letters can also be used to name an arc. That's why it's very important what you put on the top of it there. All right, and then we also just need to note that it measures less than 180 degrees. Measures less than 180 degrees. All right, we're almost there, almost there. So the last little section there is just a reminder about a few things. Remember, a circle has 180 degrees. A semicircle is half of that, which is 180. Don't forget about vertical angles because we are going to use them here in this unit. And then do not forget about linear pairs. Remember, a linear pair are 2 angles that form a line together. So that was a little sloppy. Let's do that again. So 2 angles. We have an angle here and we have an angle here that form a line together. And therefore, they're supplementary. Remember, supplementary means they add up to 180 degrees. All right, so that's a linear pair. Remember, vertical angles are basically when you have an X, and those are equal. Those are congruent. Now, central angles are huge in this unit. A central angle is an angle whose vertex, remember, that's the pointy part of an angle, is at the center of a circle. So if we put the vertex at the center of the circle, it would look like that. That is a central angle. I can make another central angle. So this becomes a central angle. This is a central angle. I can make several central angles, but I'm just going to put one for the point here. But notice the vertex is on the center of the circle. That makes it a central angle. Center, central, center, central. So that angle there, it's pretty important to know the relationship between the angle. Let's say that this, I'm just going to do some thinking here so you don't have to draw this. Now remember, a semicircle is 180 degrees. Half of 180, which would be there, would be 90 degrees. That would be more like that. So obviously my pink angle there is even less than 90 degrees, if you follow that. But if not, I'm going to give you the degree anyway. You're not going to know just from looking at it, so I'm just going to give you a degree that I would say it's about. So let's say it's about 50 degrees. So if we know that that angle is 50 degrees, we actually know that this arc also measures 50 degrees. This arc up here. So the relationship between a central angle and the arc is that they're the same. So the measure of a central angle is equal to the measure of its arc. The measure of its arc. Now, its arc is also referred to as the intercepted arc, but it's important to know that when I say its arc, I mean the arc that basically it's opening up to, that the angle itself opens up to. It's not talking about an arc over here. That is not the arc for that angle. So I kind of think of it as, it's eating its arc. If you think of the entire figure as almost like a Pac-Man. The angle is eating its arc. That is the arc that it's going to be the same as. All right, so I know that's a lot of vocabulary, but that's all the vocabulary we're going to need to use for this unit, or mainly use for this unit. So make sure you keep this and you keep it handy for throughout the unit, because really it's the foundation for what we're going to be doing. right.